Hi, good afternoon. This is to introduce the lab, which is simple harmonic motion. I will share with you several things in here. The first thing is the instruction. This one here, simple harmonic motion, virtual updated. That one is here. Okay, then you're gonna get the instructions here. I will go over it with you. I will share with you my Excel file, and also there is another document that I have prepared just to help you in finalizing your final report. Now the first thing is we are going to study, as was outlined in the lecture. We have two systems. One of them is called the simple pendulum, and the second one is the mass spring system. I have divided the lab into 1, 2, 3 task for the pendulum, and there is another task for 2 tasks for the spring mass system. Okay, now both of them are really based on simulations. And just to share with you the simple pendulum lab, it's here. Okay, you're gonna set here, if you can see. Okay, as I said, this is a formal lab report. You're gonna set your length to 0.8 for you. Okay, remember, my numbers always might be different from yours. Even the document that I will share with you, it might have different numbers, but you're gonna follow what I'm asking you now. Okay, then here you are going to have your the length as 0.8. And now for the mass, I did believe I'm using 0.6. Let me check here. Okay, I have it 0.8 for the length. The angle is constant at 15. Yeah, the first task, we're gonna change the mass. Okay, and then the angle should be constant at 15 degrees. Okay, then here this is when we're gonna start, and we are going to change the mass from 0.2 okay to 1, I believe. Okay, like I will forget from the time that I'm gonna move from here to here. Yeah, from 0.2 kilograms to 1 kilogram. Now you are going to measure the time needed for 10 oscillations each time you change the mass, and then you are going to calculate the time needed for 1 oscillation. Here you are going to record the T10, which is the time for 10 oscillations, but here you will calculate the time for 1. Then this number here divided by 10 is gonna be the period. Why we are measuring 10 oscillations? Because the time for 1 oscillation is really small, and if we are going to consider just measuring 1, our uncertainty in time is going to be very large. And then we are going to record the data here. All right, then this is really the first task. Let me show you here how we are going to do this. Okay, like I started here with 0.2. Okay, the angle here is gonna measure negative 15, and this is how I'm gonna make my system oscillate. But I want to make it slow here. Okay, so that I will be able to say, and you can start your stopwatch like here. Let me show you. There is a stopwatch here, or you can start the stopwatch from your phone. Okay, you can start by saying, okay, let me start from here. Okay, and then okay, let me wait till it reaches the highest point, and then okay, this is gonna be this is 1. All right, and then let's have it normal. 2, 3, 4, and then you're gonna count, like it's easier when you have it slower. You're going to, like, every time, let me repeat this, from, let's say from here, if this is my starting point, this is half of the cycle, and when it's gonna come back, this is 1 full cycle. Remember, we discussed this in the lecture. Then this is 1. Okay, and then I'm gonna wait till it comes to the side again, and this is 2. Okay, and of course you are going to use either this stopwatch or you're gonna use your own stopwatch. Okay, then okay, this is really the first task. The second task is we are going to understand the relation, or find out what is the relation between the period of the pendulum and the initial angle, and therefore we are going to have the length constant at 0.8 meters and the mass constant at 0.6, and we are going to change the angle from 5 to 25. I'm gonna go back here and show you. Okay, I'm gonna keep that 0.8 for the mass. I'm gonna keep it at 0.6. Okay, here. And for okay, of course gravity, we're gonna keep it earth. And then for the angle, I'm gonna start from 5 first. Okay, and I can start the pendulum. Okay, and then count 10 times. Okay, then this is 1. This is 2, and go on. Okay, and then you're going to change the angle from -5 to -10, which means my angle is 10. I forgot if, like, what are this, like the increments here. Let me look at it. From 5 to 25 in steps of 5. That's correct. Okay, and then you are going to again find the time, measure the time for 10 oscillations, and then also calculate the time for 1 oscillation. The last task related to the pendulum, we are going to study the relation between the period and the length, and therefore we are going to have the angle here. We are going to change it into, keep it at 15, and the mass, keep it, okay, then for the angle, I'm gonna keep that into -15 so that I will keep it simple pendulum. Okay, and now for the length, I'm gonna start changing from, I think I started from 0.2. All right, let's see here, from 0.3 till 1 meter. And every time you are going to measure the, I will say the period for 10 oscillations, and then you are going to record it and calculate also what is really the time for 1 oscillation, then change the length to 0.4, do it again, and go on. Now then, this is really I will say task number 3. You are going under calculation section. You are going to have, of course, T, because this is a calculated, and you are going also to find T squared. Then you are going to record T squared. The reason is I need to have T squared, not T, is that you know, I have a square root. I need to get rid, I need to get rid of the, you know, the square root. Okay, I will use the graph of t squared versus L to calculate G from the graph, and I will show you in a little bit how we are, like, what's the relations in a little bit, but just let me finish the lab. Okay, the second one, it is the mass spring system, where I will now have the mass spring system, and I can, you will use the introduction here, introductory, and then I'm gonna have the 50, and of course again I will measure the time needed for 10 oscillations the same way. Now remember, let's say from here to come up to here, this is 1, this is 2, this is 3, but you will not do this by your hand, of course. You are going to leave the system oscillate naturally. Then you're gonna say, okay, start my stopwatch, and maybe start from here. 1, okay, this is 1, this is 2, and gone. Okay, then you are going to, if you like, you can use the stopwatch here. Okay, you can use it. If you don't like, you can use your stopwatch from your phone. You're going to remove, after you are done with the 50, you're going to remove it. You are going to bring the 100, finish the 10 again, and then also the 250. All right, then this is really task number 4. Okay, as outlined here. Choose masses and springs intra, attach 50, measure the time needed for 10 oscillations, record your measurements, and repeat that for 100 and 250. Now here we are going again to have a table for the data. Under data, you're going to have mass and T10, and the rest is going to go under what? Under calculations. Then you are going to say T in seconds, which is T10 divided by 10. You will calculate K, which is the spring constant. And also I will go over that for you in the, the handout that I told you about. Now this was task 4. Task 5, we have here we are going to have also a graph, which is going to be T squared versus K, and from that graph I will be able to calculate K also. Then I have K here from the calculation, and I have K from the graph. The last task, which is task 5, you are going to attach we have 3 unknown masses. You are going to measure their periods, T10, and of course T for the pink, for the cyan, for the yellow, and you will use the data to calculate the unknown masses. Now, using the calculated value of K, you will be able to find what is going to be the, the values for these masses. You are going also to find what is K, percentage difference, K from the graph, and the average K from the calculations here. And of course, you need to provide a complete lab report. Okay, here I will show you the, these are the masses that I'm talking to you about. Then you are going to remove this one, and you are going to have that, okay, mass. This is the pink. You're going to make it oscillate 10, and then you are going to measure the time for 10 oscillations and find the time for 10 for 1 oscillation, and then use that for the calculation. This is the handout that I was talking to you. We are studying simple harmonic motion, mass spring system, and simple pendulum. The factors that affect the period of the oscillation for simple pendulum, they are really the length and g. Okay, g, it is acceleration due to gravity, and L is the length of the pendulum. Now you're gonna see if the mass is gonna affect significantly the period or the angle. Now, of course, here my numbers are different. Stick with the numbers in the the handout that I was talking to you about, because here I'm showing you my data, and then I'm explaining to you task 1, task 2, task 3 the same way. And then finally, here I'm showing you that because we have t equals 2 pi square root of L over g, it's hard actually to have a relationship between them. When it is like this, it will not be linear. Therefore, I will square both sides. T squared equals 4 pi squared L over g. And from that, I can, when I graph t squared versus L, this is going to be a straight line. And from the slope, I can get 4 pi squared over g. Then I can use the slope to calculate g, and g equals 4 pi squared over the slope. Also, I know that for the mass spring system, the relation is, this is what we studied in the lecture, it is 2 pi square root of m over k, and I can again square and find k from the slope as well. Then you can say that the slope is going to be 4 pi squared over k, and you will calculate k from that. Now, of course, here for task 5, we have 3 unknown masses. I have T10 and T, and then I can get K from the graph and substitute it and find what is really the unknown mass, like we did in the examples in the lecture. One more thing is showing you my data here. This is my task number 1. This is my task number 2. This is my task number 3, and that is really the chart, the t squared versus L. I should have my, of course, the equation of the straight line on the graph. Task 4 is this one, and this is the graph. It's only 3 points. Also, like, I need to label my axis, I need to give it a title, I need to have an equation. And task 5, I have my masses calculated here, and you should get your values. Okay, that is for the lab, and I hope everything is clear. And then please contact me if you have any issues. Thank you.